Good morning. Good morning.
Good morning, sir.
Okay. So, are you able to see my screen? Hello.
Yes, sir.
Yes,
Okay.
sir.
So, today's topic is what memory designing or memory interfacing. Now, this is our topic for today's session. Now, as you know that we are having 20 bit of address bus. Because of that, we are having 2 raised to 20 memory locations, different addresses. So we can have maximum 1 MB of memory in 8086, right? So if this is my memory of 8086, the total size of this memory will be 1 MB. Yes? Hello.
Yes, sir.
Okay. કોઈનામાંથી અવાજ આવે છે? Can you mute your mic? When I speak, you can answer me. That would be okay. Uh, Please, all of you can mute your mic. Okay. Now let's start. So 1 MB of memory. Now there are two types of memory possible. One is called RAM, one is called ROM or EEPROM. Right? RAM is random access memory. This is read only memory. Right? You know why ROM is used? Can someone tell me why ROM is used at which place? Hello.
ઓપરેટિંગ સિસ્ટમને લોડ કરવા માટે.
Operating system ને load કરવા માટે. Okay. Wait, I will come. એક minute. I'm getting the noise from here. So okay, now are you there? Hello.
Yes, sir. Yes, sir.
યસ સર.
Okay, now the noise is gone, so now I can concentrate. So ROM is actually, as he said correctly, it is used to load the program. Normally BIOS gets stored on ROM, so it is read-only memory and it will be a permanent memory. So if this is my 8086 memory, 1 MB, okay, normally always the address will be 00000H to FFFFH, right? Here always my initial part will be my RAM, my bottom part is always a ROM. Now why is it so? Because my reset vector is stored on location FFFF0H, reset vector, right? So because of this, my ROM will be always in the bottom part, my RAM will be always in the upper part. Get it? This much stuff is clear. In my 8086 memory of 1 MB, upper part is associated with RAM, ROM will come in a bottom part. Done?
Yes, sir.
Okay, now next. Now in exam, the sum will definitely gonna come. Normally it comes in all the examination and it can come for 10 marks also. Now what you need to do is you need to design a memory map. Okay, such that you need to attach some RAM and ROM with your 8086. As you know that you can attach maximum 1 MB of memory with your 8086. Now question can come like this: design an 8086 where you need to attach 32 KB of ROM, okay, with 16 KB of chip, and you need to attach suppose 128 KB of RAM with 32 KB of RAM chip. Done. This is my example definition. I need to do this. What I need to do is I need to prepare, attach RAM and ROM with my 8086 such that I can make this configuration. Clear? Hello.
Yes, sir.
Okay. So first thing that you are supposed to do is, now if this is my 8086 memory, okay, 0000h, and this is FFFFH. As I said, my RAM will be always on top, so I know the starting address 00000 always, right? My ROM address, starting address, I don't know, so I need to find out the starting address of ROM, right? Starting address of ROM, you need to search. What is the starting address of RAM? It is always 00000h. Done? Hello.
Yes, sir.
Okay. So now, first thing that you are supposed to do is, how many ROM needed? Okay. How many ROM needed? As you are having a chip of 16 KB available with you, right? You need to prepare 32 KB. So how many chips needed? Two chips needed. Done? Hello. Is it
Yes, sir.
clear? Second, how many ROM now RAM needed? How many RAM needed? Now I need to prepare the RAM of 128 KB, and I am having 32 KB available. So 32 KB available, I need to make 128 KB. How many chips needed? 32 into 2, 64. 64 into 2, 48. So total 4. Yes?
Yes, sir.
So this is the first step, that you need to count that how many ROMs needed, how many RAMs needed. Normally and like always, in case of memory, you will get even number as output. Why? Can you tell me? Number of chips will be always even. Why? Can someone tell me? Hello? Hello? Are you there? Are you able to listen me?
Yes, sir.
Oh, okay. Can someone tell me why the number of chips needed in memory will be always in even number? Because we have seen that we are having even and odd bank, right? We need to divide our memory into two parts, odd bank and even bank. So that's why always all chips will be in even number. Get it? Then only we can fetch 16-bit data at a time, because from single chip you can access only 8-bit data. So if you want to access 16-bit data together, you require two chips. One chip will be working as even chip, one will be working as odd memory address. Done? Yes?
Yes,
Hello?
sir.
Okay, please provide feedback. I am not able to like get it that you are there or not. So this is the first step. What is the first step? You need to count how many ROM needed, how many RAMs needed. Done? Now next step. You need to count the starting address of of ROM. We already know the starting address of RAM. It is always, starting address of RAM is always 00000h. We know that. But ROM will be stored in the bottom part. So we need to find out the starting address of ROM. So that is our next step. Yeah.
Yes, sir.
Okay. So chip will get ended at, our memory will get ended at FFFFFH. Right. Minus, what is the size of our ROM? 32 KB. So FFFFF minus 32 KB will give you the address. But you can't subtract 32 KB with FFFFH. So you need to convert 32 KB into some address. Yes? So how to convert 32 KB into address? 32 KB is equal to 32 into 2 raised to 10. Yes?
Yes.
That means 2 raised to 5 into 2 raised to 10. That means 2 raised to 15. Yes?
Yes, sir.
Now write down 15 1. 1 1 1 1. 1 1 1 1 1 1 1 1. Okay, this is 12, right? 13 14 15 0, and this is 0. 1 2 3 4 and 5. So if I convert this into hex number, this will be 0, this will be 7 f f f. Yes, get it? This is
Yes,
my
sir.
size of 32 kb in hex number. So if I subtract f f f f f minus 0 7 f f f, what will I get? 0 0 0 8 f. Yes.
Yes, sir.
So this will be the starting address of my ROM. Get it?
Yes, sir.
So what we have done, first we have find out how many chips will be needed if you want to make that memory. This is your question. You need to design 8086 such that you need to make a 32 kb of ROM. You can make 128 kb of RAM using this chip and using this chip. So first thing that you are requiring is find out how many chips are needed. So two ROM chips are needed, four RAM chips are needed. The starting address of your ROM will be F8000. Why? Because it's end at FFFFF, so we need to subtract the total size of ROM. Done?
Yes, sir.
Yes. Okay, so this is step number 2. Now step number 3. Okay, just for your sake of understanding, we'll write down this is my step number 1. Okay, this is my step number 2. Now this is my step number 3. Now what I supposed to do is how many address lines needed. Okay, this is what we need to count. How many address line will be needed? One for ROM and one for RAM. Now, as you know that we are having 20 bit of address bus. Because of that, we are having 1 MB of memory, right? So from address bus, we can find out the memory. Same way from memory, we can find out the address bus also. So our total size of ROM is what? 32 KB.
Yes,
Hello.
sir.
And what is the total size of RAM? 128 KB. Yes, in question. Hello.
Yes, sir.
Okay, but we need to give the address bus to chip, not to total memory. And our chip size is 16 KB in ROM and 32 KB in RAM. Yes.
Yes, sir.
So we don't need to consider this. We need to consider chip, individual chip, because we need to provide the address bus to the individual chip. So we need 16 KB chip. We need 32 KB chip, right? So for ROM, how many address bus are needed? 16 KB. So a normal formula 2 raised to 4 into 2 raised to 10 is equal to 2 raised to 14. That means 14 address lines are needed, right? Yes.
Yes, sir.
So if I want to access my ROM all the memory locations, I require 14 address lines. Okay, and same way for RAM, if I need to convert 32 KB, simple. 32 is 2 raised to 5 into 2 raised to 10 is 2 raised to 15. That means 15 address lines will be needed. Yes.
Yes, sir.
Now, next question. Which address lines you are giving to RAM and ROM? You can share the common thing, but you can have A0 to A13, right? You can have A0 to A14 here, but we can't use A0. We can't use A0. Why? Can you tell me the reason? We have already studied. Hello, are you there? Hello, are you
Yes,
there?
sir.
Okay, you can't use A0 because already I told you your bank memory is divided into two part, even bank, odd bank. Okay, even bank, if you want to select, you need to give A0 as your signal. If you want to select odd bank, you need to use BHE as your signal. So A0 and BHE are used as chip select signal to select your memory bank. Get it? So we can't use A0. It will be default use for memory chip select signals. So if I need 14 lines, this will not be correct. You need to use A1 to A14, and here you need to use A1 to A15. Done? This much step is clear?
Yes, sir.
Okay. Again, just for the sake of revision, let me do it again. What we are trying to do is we need to attach memory chips with our 8086. Now in 8086, this is my 1 MB of memory. The upper part is occupying by RAM, bottom part is occupying by ROM. Why? Because my ROM is storing the permanent address. BIOS. My reset vector is stored on location FFFF0H. That means on a bottom part, right? So
Yes, sir.
because of that, sorry, because of that, the bottom part will be ROM, upper part will be RAM. So RAM will always start with location 0000000H, 5H, right? Bottom part ROM will start with which location that we don't know in advance, so we need to find out the address. So example will come like this. You are having a 32 KB, you need to make a 32 KB of ROM using 16 KB of chips. You need to make a 120 KB of total RAM using 32 KB of RAM chip. Now, step one, you need to count how many ROMs will needed, how many RAMs will needed. Simply, this is not difficult, right? Divide total by the chip available. You will always get even number. Why you will get even number? Because your memory bank will be divided into two parts: odd bank, even bank. So chip will be always in the form of odd even. Fine. So it will be in even number only. Hello.
Yes, sir.
Second step will be you need to find out the starting address of ROM. If you want to find out the starting address of ROM, the ending address will be FFFFF. You need to subtract your total size of ROM. Total size of ROM is 32 KB. How to find out number from 32 KB? 32 into 2 raised to 10, 2 raised to 5 into 2 raised to 10, 2 raised to 15. If you represent 2 raised to 15 in binary form, it will look like this. This is the ending number. So 07FFF is 2 raised to 15 in hex. Subtract this from your last location and you will get one address. So this will be the starting point of my ROM. Fine.
Yes, sir.
Same way, step 3, you need to find out how many address lines will be needed. Yeah. So address line will be needed based on the chips available. You are having 16 KB of chip available and you are having 32 KB of chip available. So 32 KB you require 14 address line, 32 KB you require 15 address line. Address line you can't allow A0 because it is default used for chip select. So you need to select A1 to A14 and here you need to select A1 to A15. This much thing is clear.
Yes, sir.
Yes, sir.
Okay, next we need to make memory map, right? Because if RAM is attached and I want to access something from RAM, how can I access it? That I want to check. So you need to draw like this: A0, A1, A2, A3, A4, A5, A6, A7, A8, A9, A10, A11, A12, 13, 14, 15, A16, 17, 18, and 19. These many address lines are available. Yes, yes.
Yes, sir.
We are having 20-bit address bus, so we need to draw all that 20 bits. Fine. Now, always start doing memory mapping with your RAM. So my first RAM is always starts with which location? Hello. Now, make sure that A0 is separate, right? So initially it will be suppose 0, 0, right? This will be my RAM 1. Okay, the starting address of my RAM will be 00000. Yeah. So here all zeros. This is clear. Uh,
Yes,
the
sir.
starting address of my RAM 1 will be 00000 and it will be 0. That is fine. Hello. Hello. Are you there?
Yes,
Yes,
sir.
sir.
What will be
Yes,
the
sir.
ending? What will be the ending address of my RAM one? Now the size of my RAM one is 32 KB. Yes. Hello. Size of my RAM is what? 32 KB. Again, you need to do the same procedure. If it is 32 KB, what is the ending address? 2 raised to 5 into 2 raised to 10.
And
2 raised to 15. Right? So you are having 15 address line which will get changed. Which are the 15 lines which will get changed? A1 to A15. Yes.
yes, sir.
So here you need to change the line A1 to A15, and all of the line will remain as it is. So it will be like this: 1 1 1 1 1 1 1 1 1 1 1. We'll change that. So we have changed it, and if you can now convert this into number, this is my 1 1 1 E is E. This is F. This is F. This is F, and this will be 0. So 0 F F F E. Here my first RAM will get ended. Yes.
Yes, sir.
Now I need to attach my RAM 2. Now this is actually, if you can see clearly, this is my RAM 1. Now I need to attach my RAM 2. How many RAMs we need to attach, by the way? Total?
Two.
Not 2. If you can see it here
Four,
carefully,
four.
yes, 4 RAMs are there. So we need to attach 4 RAM. So now RAM 2, RAM 1 and RAM 2. RAM 2 will be very simple. This is my E1 bank. Yeah.
Yes,
So
sir.
now this will be my odd bank. So simple, I don't need to do anything. I need to make A0 as 1 1 here. Everything else will remain same. 0 0 0 0 0 0 0 0 0 0 0 0. This will be 0 0 0 0 and 0 0 0. So this will be 0 0 0 1 H. Fine. And here also everything will remain same. Only 1 1 1 1 1 1 1 1 1 1 1 1. So that means 0 F F F F H. Done. So now this will create a single band. This is called my first band. Two chip are used. One is used for even bank. One is used for odd bank. Get it? Hello. Are you there?
Yes, sir.
સર
Okay.
સમજ નથી પડતી.
Sir, zero
Okay.
zero one અને
Huh?
zero FF વાળું નથી ખ્યાલ આવ્યું.
Okay. We'll start again from the scratch. So forget it. Chalo. This is clear. Your RAM is for 32 KB. So 15 lines are used for address bus. This is clear.
Yes,
યસ.
sir.
A1 to A15 will be your address bus. Now concentrate again. Suppose let's say, sorry, A19. Sorry, we'll start with this. A0, A1, 2, 3, right? A4, A5, A6, A7. Fine. A8, 9, 10, A11. A12, 13, 14, and 15. A16 to 19. These are the four parts of your hex code. 20 bits. This is clear?
Yes, sir.
Yes. Okay. Now suppose we'll start with RAM 1. Okay. So RAM 1 starting address is what?
Zero zero
Okay.
four
It is
zero.
starting with 0, right? Make A0 separate. So A0 is initially 0. And this all bits will be 0. So this will be 0, this will be 0, this will be 0, this will be 0, and this will be 0. Right? So if I convert this all into hex number, this will be 0 0 0 0 H. Done?
Yes, sir.
યસ સર.
Hello, are you there?
Yes, sir.
Okay, now we have not used A0, so it will remain 0. Fine. And what will be my ending address? I need to change the bits of A1 to A15. Yes?
Yes, sir.
So A1 to A15 I will change. So all becomes 1. And this will remain as it is 0. Fine. So if I
Yes, sir.
convert this into hex number, this is 0. This is all 1, so F. This is all 1, so F. This is again all 1, so F. This is, what is this? 1 1 1 0. So this is E. Yes.
Yes, sir.
So E. So this is my ending address of my first chip. Get it?
Yes, sir.
And as you can see, it is ended with 0 and F's. This is my E1 bank. Fine. Now I need
Yes,
to
sir.
make my odd bank. So odd bank will be like this. So RAM 2 will be used as odd bank, and it will be, we change A0 with 1 1. Yes.
Yes, sir.
So what we have done, simple, A0 with 1 1. Everything else will remain same. So 0 0 0 0 0 0 1 1 1 1 1 1 1 1 1 1 1 1 and 1 1 1. Everything will remain same. In second chip, you just need to make your A0 as 1. That's it. Yes.
Yes, sir.
So now here my number is 0 0 0 0 1 H, and end number is 0 F F F F F H. Done.
Yes, sir.
Yes,
So
sir.
I have attached two RAM with my processor. One will work as even bank, one will work as odd bank, and this totally working as a band. This is called band, one band. Right?
Yes, sir.
Done.
Yes, sir.
Now I need to attach two more RAM, right?
Yes, sir.
So the address of my next RAM will be from this. This is the end of my second RAM. The third RAM ક્યાંથી ચાલુ થાય? આની પછીના એડ્રેસ પરથી, બરાબર?
Yes, sir.
So 0 F F F F plus 1. ત્યાંથી મારી actually બીજી RAM ચાલુ થાય. What is the address? 0 0 0 0 1. If you do addition, this will be the number. Yes.
Yes, sir.
So my next RAM address, starting address will be this, 10,000. Done.
Yes, sir.
So RAM 3 will start with location 10000H. Write it down here. So 10000000000000000 and 0. A0 is 0. Done.
Yes, sir.
Hello, everyone is there?
Yes, sir.
Next is same. A0 will remain 0 only, and you need to change bits till 15 because it is our 15 address needed. So 1111 1111 1111 111, and this will remain as it is 1000. No change. Done. Now what will be the address of this? First is 1. This is F. This is F. This is F, and this is E. So this is my ending address. Done.
Yes, sir.
So this is the starting address and ending address of my RAM 3. Fine.
Yes, sir.
Now I need to make the odd bank. So simply change A0 with 1 1. Put it everything as it is. No change. No change. So what happens? It will become 10001H and 1FFFH. Yeah. And this will be my RAM 4.
Yes, sir.
Odd bank. So I have attached all my RAMs with my 8086, and these are the starting and ending address of my all RAMs. Done.
Yes, sir.
Again, just for the sake of revision, concentrate. What you are supposed to do is, if number, you first need to find out how many address lines will be needed for by your RAM. If it is needed 15 address line, you need to change A1 to A15. If 14 address lines will be needed, you need to change A1 to A14. So first thing that you need to do is you need to find out this. Once you are done, you need to make even bank, odd bank, even bank, odd bank. So your A0 will initially 00, then it will be 11, right? And you need to change the number and you need to write down the hex number. It is as simple as that. Once your one band will get over, you need to add 1 in your final address. You will get the starting address of another band. Yes.
Yes, sir.
Okay, this thing requires practice, so at your home you are supposed to do practice. Fine. One more time, then the sound will get clear. This much thing is clear. Hello.
Yes, sir.
What we have done is we have attached RAM with our 8086. How many RAMs we have attached? 4. Done. But if you have seen the sum carefully, now we need to attach ROM with 8086. How many ROMs we need to attach?
2.
2. What is the starting address of ROM? If you know the starting address, we have find it in initially only F8000H, right? So simple. If you want to write down the starting address of ROM, so ROM 1 starting address is 0, sorry, F8 Sumatu, F8000. So this will be my starting address of ROM F8000H. Write down in the form of numbers 1111. 8 is 100000000000 and 0000. Done. This is the starting address. What will be my ending address? Again, same concept. We are having how many lines? 14 lines for ROM 1. We have already find out. So A1 to A14 will get changed. A0 will remain as it is. So this will remain 0. This is 2, 3, 4. Sorry. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and this is 15 onwards, so this will remain as it is. So 1 1 1 1 1, this will remain as it is. Everything else will get changed. So 1 1 1 1 1 1 1 1 1 1 1 and 1 1 1. If you convert this number into hex, this will be F F F F E H. Done. Hello.
Yes, sir.
Yeah.
Yes, sir.
Yes, sir.
This will be my E1 bank. Okay. Now, if I want to make the odd bag, I simply need to change 0 with 1, 1. Everything else will remain as it is, same. So here, what will get changed? F8001H, F, 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 H, and my memory will get ended. This is my odd bank, and this will be my ROM 2. Done.
Yes, sir.
This much stuff is clear.
Yes, sir.
Yes, sir.
Though it is difficult, go through this video again. Fine. So which are the steps? We'll do the revision once very fast so that you can attend your next lecture easily and fast. First, sum will be given to you. Fine. Step 1, find out number of chips needed. Get it? Yes.
Sir.
Step 2, you need to find out starting address of
Rome.
ROM. Right. Step 3, you need to find out how many address bus will be needed. Fine.
Yes, sir.
For ROM and RAM. Now, what are the things that you need to take care? You can't consider A0. Okay, here you need to take A1 onwards. Fine. Starting address of ROM, you need to take F, 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 H minus something size of the total ROM. Fine.
Yes, sir.
Okay. While calculating the number of address bus, you need to select the chip size, not the total size. Fine, because you are going to give the signals to chip, not to full size. Fine.
Yes, sir.
And then you need to make the memory map. Fine. Step 4 is memory map. Memory map is always starts with RAM because RAM addresses will be 0000H. Fine. Yeah.
Yes, sir.
Then based on the number of address bus, you need to find out the ending address of RAM 1. Once you are done with ending address of RAM 1, for RAM 2, simply keep everything as it is, only change A0. Yeah.
Yes, sir.
Once this is done, now add +1 to ending address of RAM 1. Fine. So that will be
Yes,
the
sir.
starting address of RAM 2. Follow the same procedure. Change all A1 to number of address bus that you have searched. Right. Keep A0 is equal to 0. So this is your RAM 2. Okay. and sorry, this will be your RAM 3, and then A0 is equal to 1 will be your RAM 4, right?
Yes, sir.
Okay, and for Rome, you already have searched the starting address, so write the starting address directly. Okay, plus to find out the ending address, then you need to do starting address plus size of the chip. Fine, you will get something. At that point of time, A0 will be 0. For the next time, you need to make A0 is equal to 1, and it will be treated as odd bank. This will be my even bank, and my example is clear. This number of chips and everything can get changed, but the procedure will remain this only. Done?
Yes, sir.
So I hope this is little bit difficult, not easy, but the sum can come in your exam for 10 marks also, and it can be asked in different ways. Fine.
Yes, sir.
So better go through this same sum 2-3 times video, then you will get it easily. एक बार में कदाच खबर नहीं पड़े, बराबर?
Yes, sir.
Okay, so that's it for today's session. We'll send you the link soon.